Launch Advanced Design and start a new Advanced Design project. Skip the first page by clicking Next, and on the second page define your default settings for the project. Choose the workspace type by selecting the 3D radio button. Select the Bending Rigid Structure option. For material, select C2530 and click Finish to close the Project Settings dialog box. Save the project using the Save As command from the File menu. In the Save As dialog box, enter the project name Concrete Building. Select Mesh from the Options menu. In Mesh Options dialog box, select the Grid type from the available drop-down list. This is a quicker and simpler form of meshing than Delorme, but it is suitable for rectangular structures such as the one we were about to create. Create a subsystem tree so that we can group together the same types of modelling objects. In the pilot, right-click Structure and from Context menu select Systems Management, create a subsystem. The name field is automatically active after you create a subsystem, so immediately type in ground level for its name. Click on the top level system called Structure, then click F6 to create a new subsystem. Call this Story 1. In the same way, create Story 2. Now select the ground floor subsystem, right-click and select System Management, create a subsystem. Call it Foundations. Create two more subsystems called Beams and Walls. Create Beams and Wall subsystems under the remaining two levels. Select the ground floor subsystem. Enable Level in the subsystem's properties. Type 4.5 for Z top. This means that if this subsystem is selected when a new structural object is created, it will automatically be placed within this band between Z equals 0 and Z equals 4.5. Select the Story 1 subsystem. Type 9 for Z top and 4.5 for Z bottom. Define Story 2 Z top and Z bottom as 12 meters and 9 meters respectively. Select the work plane's origin axis, and in the Properties window, enter 3M for abscissa and ordinate. Now we will change the view. Right-click on one of the toolbars and select Predefined Views from the Context menu. Click the Right View button. The view is now in the YZ plane. On the Work Plane toolbar, to project the work plane on the active view, select the Define a Work Plane by Projection on Active View button from the Work Plane toolbar to project the work plane on the active view. Click the Zoom All button on the Zoom and Views toolbar to see the whole structure. Select the Ground Level Wall subsystem. Select the Create a Vertical Planar Element by 2 points command from the Modelling toolbar. For thickness, type 180 mm for the first vertex value. Click anywhere on the Z-axis and the cursor snaps to the top of the current level. Move the cursor in the positive Y direction, type 1.5 and press Enter. Select the planar element and copy it once by 4.5 meters in the positive Y direction. Now click on the top right corner of the first planar element to start stretching it and move it sideways. We want to move this corner along the Y-axis, so to help guide its movement, we can switch on the ortho snap by pressing F8. Now move the cursor so the corner has moved in the positive Y direction and type 1.5, then Enter. Do the same with the bottom right corner. Select the second wall element and copy it 3 times by 3 meters in the positive Y-axis direction. Select the last wall element and stretch it 1.5 meters to the right as with the first one. Select the ground level beam subsystem. Click Create a horizontal linear element by 2 points on the modelling toolbar. In the cross-section category, click inside the Extremity 1 cell and click here to access the Define dialog box. Enter a height of 450 and a width of 160. In the Eccentricity field, select 0Z. Using the automatic snap modes, draw the beam between the wall elements. Select all elements by pressing the Ctrl+A. Copy them 10 meters in the positive X direction. Now select Front View and project the work plane onto the active view. Then select a 1-1-1 view from the predefined views toolbar and get a 3D view of the ground floor elements. Click Zoom All to center the model in the graphical window. To create the transversal beams, select Create a horizontal linear element by 2 points. Click the cross-section Extremity 1 cell and open the Define Geometry dialog box. Create a rectangular cross-section of height 600 mm and width 200 mm. Draw the first transversal beam between the top corners of the opposite end walls. Select the transversal beam and select the Copy command. Select the translation defined by a total vector mode. Type 11 number of copies and click here to define the copy vector. Click on one end of the transverse beam and click again at the far end of the wall where you want the last copied wall to be. Click Preview to check the effect and then click Copy and Close. Select the ground level foundation subsystem. Select Create a linear rigid support from the modelling toolbar. Select the restraint type as Hinge. Draw the linear supports at the base of each wall on the ground level. Select the ground level wall subsystem. Select Create a horizontal planar element from the modelling toolbar. Define the first vertex thickness as 100 mm. Draw the slab as shown here. Select the ground floor beam subsystem. Right click and choose the Select command from the context menu. Then select Copy. In the vector field, type the copy coordinates 0, 0, 4.5. Type 1 for number. Click the Advanced tab to reveal more options. Select Destination System and from the drop-down list select Subsystem 7 beams, which corresponds to the Story 1 system. The number corresponds to the subsystem ID number in the pilot, so you can distinguish between subsystems with the same name. Click Preview to check the effect and then Copy. Copy the walls on the slab from the ground floor to the Story 1 system following the same procedure. Select the Story 2 wall subsystem. Select Create a vertical planar element by 2 points from the modelling toolbar. In the Planar Elements Properties window, type 180 for first vertex in the thickness category. Define the first wall by snapping to the top extremities of the second level wall as shown. Select Story 2 from the pilot and modify the level height from 3.5 meters to 3 meters. Top limit 12, bottom limit 9. Select the Story 2 beams. Then select Create a vertical linear element by 2 points from the modelling toolbar. Click in the Extremity 1 cell and open the Define Shapes dialog box. Create a square of side 300 mm. Place the column as shown. Then select Create a line from the modelling toolbar. Draw a line between the top of the column and the top right corner of the wall. We will use the line to cut the wall. Select Zoom Window from the Zoom and Views toolbar. Then draw a window around the column and wall by clicking the left mouse button once to define the top left corner and again to define the right corner. Select the line. Select the Modify menu, CAD, Cut. Click inside the area of the wall above the line. With the line still selected, press the Delete key to delete the line. Zoom out so we can see the whole structure again and select the wall and column. Select Copy. Type the vector -10, 0, 0. Make sure that the Destination System option is deselected and copy the selection. Select the Story 2 beam subsystem. Select Create a linear element from the modelling toolbar. Set the eccentricity to 0, 0. Then define the cross-section as a rectangle of height 400 mm and 200 mm width. Draw a beam from the top of the column to the far end of the wall. Do the same on the other side. Now change the cross-section's height to 650 mm. Draw a transversal beam as shown. Select the Story 2 Wall subsystem. Select Create a planar element. Give it a thickness of 200 mm. Then snap to the tops of the columns and walls as shown. In the pilot, right-click Loading and select Create several case families from the context menu. Type 1 for live loads and 2 for seismic loads, and click Create. The load case families and their load cases are added in the pilot. Select the live load case. Select the first floor slab. Right-click in the drawing area and select Load Selection from the context menu. Type -3.5 for FZ and OK. Then select the second floor slab and enter a load of -3 kilonewtons per meter square. Select the top slab and enter a load of -1.75 kilonewtons per square meter. Select the seismic load case family and set the soil type to C. By default, a seismic load is in the X direction, so we will leave the first seismic load case as it is and change the second seismic load case's direction to Y. From the Assumptions section of the pilot, select Modes. For mode number, type 5. For masses definition, select Masses obtained by combining static loads. Click in the Combinations cell and open the Combinations dialog box. This dialog box allows you to choose which existing loads will be combined to calculate the masses and to set a factor. Select 1Q and click Add and click OK. From the Analysis menu, select Create the Analysis Model. Then click FE Calculation and OK. When the calculation is complete, right-click on one of the toolbars and tick the Rendering toolbar. Select Ghost Display from the Rendering toolbar. Right-click in the drawing area and select the Display Nodes option. Click the Result Settings button on the FE Results toolbar. Select Displacement, Linear Element and Display Mode Deformed. Then select Planar Element and Display Mode Deformed. Click Case Combinations and make sure only the first seismic load case is selected in the Displacements tab and click OK. Click Save View on the FE toolbar to save the view of this result. Select a beam from the first level. Check the outline of the selected element to make sure the right element has been selected. If more than one element overlap at the point where you click, you can press the Tab key to switch between the different possible selections. With the beam selected, right-click and select Cross Sections Stresses from the context menu. Select SXY and load case 1Q. You can view the stresses at any point along the member, either by moving the slider left or right, or typing in a distance from end 1.